Hello everyone, this is Dodge. Today I would like to talk about a roadmap to a successful technical interview. Basically, I want to have a checklist of topics that as an interviewee, what should we prepare and pay attention to. Okay, let's get started. Before we jump into the actual content, I would like to briefly explain my motivation of this channel. Why am I doing this? Well, from personal perspective, I want to help myself brush up my interview skills. We have to admit that day-to-day job skills are quite different than the interview skills needed. That's the reason I want to depict an overall picture of what we need to prepare for the potential new job in the future. Also, I hope this can help you as well to better understand various interview-related topics from my point of view. And the best way to learn is to teach others. I will try my best to cover topics that I listed in the next several slides during the coming months. So stay tuned and please subscribe to this channel. In this video, I will cover 5 major sections listed here. First is algorithm problem solving. You can never put too much emphasis on algorithm problem solving, because it is kind of the de facto most significant part for the majority of current software engineer technical interviews. Also, this section requires most of amount of the time for learning and practicing. The second section is CS fundamental. This part might not be asked as a raw question, although small to medium-sized companies do directly ask those questions. This should be treated as a necessary part of candidate. If you are not clear with those basic concepts or mechanisms, it can be a serious red flag for hiring process. The third section here is object-oriented design, or we call it OOD shortly. The next part is system design. And the final section of this video will be culture fit, or various alternative names like behavioral question, leadership, project stories, or simply sell yourself well. For algorithm problem solving section, we mainly deal with data structure and algorithms. I listed common data structures and popular problem solving methods here for easy reference, starting with complexity analysis or big O annotation, which is the preliminary requirement for all other topics in this slide. We should get ourselves familiar with linear data structures like arrays, strings, linked lists, stacks, and queues. Then we move on to nonlinear data structures like hash tables, trees and tries, heaps, graphs. Some quick comments here is tries are effectively trees, but it's still good to call them out separately. And for graphs, we should master common traverse methods like breadth first search or BFS and depth first search or DFS. Then we should fresh the understanding of popular algorithms like sorting, searching, recursion or backtracking, and some advanced methods like dynamic programming, greedy algorithms, and invariants. For now, it's just a simple checklist, and we will talk about each topic in depth in the future videos. Move on to the next section, CS fundamentals. I list the 4 subjects that are important here: operating systems, computer networks, database, and object-oriented programming. Let's check them one by one in the next 4 slides. For operating systems, I listed several sample questions here to offer you a glimpse on what we need to know in this area. What is a thread? What are the differences between process and a thread? Given multiple core processors have been widely used, it makes sense that developers should have solid understanding about this process and thread concepts, as well as multi-threading related topics. Other popular questions can be: what are different scheduling algorithms? What is deadlock? And what are its 4 necessary conditions? What is virtual memory? How is it implemented? What is inter-process communication? How does it work? For now, we will skip the details and move on to the next slide For impatient audience here, we could not stop you from searching results using Google to get an answer here. Let's have a quick look at computer networks. Today, it's hard for a developer not to interact with various computer network related stuff. We should have a good understanding for what happens when you type a URL in a web browser, and also be able to clearly describe about each layer in the OSI model and TCP/IP model. Other popular questions can be, what is TCP three-way handshake? What is the difference between TCP and UDP, HTTP and HTTPS? How DNS works? This section contains lots of advanced topics, and for a general software engineer, we should master the very basic and core concepts to ace our interview here. Okay, let's move on to database. Know that lots of buzzwords fly around this area, like NoSQL, big data, etc. But it is still quite beneficial for us to master the database core concept, like what is ACID properties of transaction, and what is database normalization, what are its advantages and disadvantages. We should know the basic CQ statement to CRUD, create, read, update, and delete, and understand what is an index in a database, and what is the primary key in relational database. We should also be able to explain what is a SQL join and why do we need it, and can answer modern questions like, what is the difference between relational database and NoSQL database? Now let's move on to object-oriented programming. We should be familiar with those basic concepts inside this area, like explain the basic concepts of OOP, inheritance, encapsulation, polymorphism, abstraction, define overloading and overriding. What is the difference between a class and an object? What is the difference between public, private, and protected access modifiers? What is the difference between abstract class and interface? Okay, let's take a look at this object-oriented design. Object-oriented design has always been a critical part of software engineering interview process. Most of engineers struggle with the object-oriented design interviews, partly because of their lack of experience in laying down the design of a complex system, and partly because of the unstructured nature of OOD. Even engineers who have some sort of experience in building such systems are not comfortable with these interviews. It is mainly because of the open-ended nature of the design problem that don't have a standard answer. We should prepare ourselves well in this section. Here I listed some sample questions for quick reference. Design an ATM. Design an elevator. Design a parking lot. Design a blackjack, a card game. Design a hotel management system. Design Facebook, a social network. Design Amazon, an online shopping platform. Let's move on to the next part, system design. System design questions have become a standard part of software engineering interview process. Performance in this interview reflects upon your ability to work with complex systems and translates into position and salary the interview company offers you. Most engineers struggle with system design interview, partly because of their lack of experience in developing large-scale systems, and partly because of the unstructured nature of system design. Even engineers who have some experience building such systems aren't comfortable with these interviews, mainly due to open-ended nature of system design problems that don't have a standard answer. Here are some sample questions that we might meet during interview. Design a tiny URL, a URL shortening service. Design YouTube, Netflix, or Twitch, a global video streaming service. Design Facebook Messenger or WhatsApp, a global chat service. Design Quora or Reddit or Hacker News, a social network plus message board service. Design Dropbox or Google Drive or Google Photos, a global file storage and sharing service. We arrived at the last section of this slide, culture fit. Culture fit is basically a catch-all for everything that you are doing in your interview that is not coding. This might be talking about your side projects. It might mean discussing why you are interested in this company. Whatever it is, the best way to succeed at these interviews is to practice and then go in prepared. Here are some sample questions. Give me an example of a time when you were able to deliver an important project on the tight deadline. What sacrifice did you have to make to meet the deadline? How did that impact the final deliverables? What's an example of a difficult problem you solved? Be specific about how the problem was diagnosed and your process for approaching it. Give me an example of a time when you had a difference of opinion with a team member. How did you handle that? Can you tell me about your team's decision-making process? What do you like and not like about it? And that's all for this video. I will publish new videos in this channel to cover all other topics. So see you next time. Bye.